Hi everyone, welcome to UTA Planetarium's live star stream. We are here with you again. My name is Levent Gurdemir. I am the director of UTA Planetarium and UTA astronomer. And in today's live stream, we will cover a lot about the solar system. It's actually the first episode of the FU series. So we decided to talk about the solar system because there was a survey we released a few weeks ago, and the top requested topic was the solar system tour. So apparently our audience would like to know more about the solar system. So if we start exploring the solar system, where we should start? Should we open another survey for that? But I don't see the reason for that. Let's start from the center, because I think the biggest and heaviest thing is sitting at the center of the solar system. So you know what I'm talking about, right? The sun. Yes, the sun is a star. It's like other stars, hot glowing gas sphere that produces 384 yodawatts of energy. Probably you never heard that the energy unit before, because we don't need to use that type of large units in our real life. So the sun produces that energy by burning hydrogen, which is the most abundant element in the universe. The sun is an average star, but odd enough, we call average stars dwarf stars. So the sun is a dwarf star. It is still so massive, well, because stars are. The 99% of the weight in the solar system is in the sun. So the sun is 1,000 times more massive than the biggest planet of the solar system, Jupiter. So the sun is a G2 type star. G2 is the temperature class. So the sun is nearly 6,000 degrees on its surface. The temperature of the stars determine their colors. So hot stars burn blue and cold stars burn red. What is the color of the sun? I think I can hear yellow, right? In fact, the sun emits green color more than other colors. And in theory, we should see the sun as green star. However, our eyes are not sensitive to the green light as much as other colors. Therefore, our star looks white, which is combination of all the other colors. So why we see the sun yellow in the sky? Well, there's a reason for that, because the air reflects most of the high frequency colors back into space, such as blue and violet, and refracts, which means diverts, most of the lower frequency colors such as orange and red. So the yellow light passes through without any problem. That's why we see the sun as a yellow star. This changes in the sunset though, right? Because the sun turns into a red color sometimes during sunset, because highly refracted red light reaches to our eyes. So let's explore the planets. We have mainly two categories of planets in the solar system. The closer planets are called inner planets or terrestrial planets. Terrestrial is a Latin term for Earth-like. The inner planets are Mercury, Venus, Earth, and Mars. The outer planets are Jupiter, Saturn, Uranus, and Neptune. Should I count Pluto in here too? Well, it doesn't matter. Pluto was called a planet. Now it is called the dwarf planet. Doesn't matter. We'll talk about Pluto at another episode, maybe when we come through the outer planet section of this solar system tours. But I would like to talk about the closest planet to the sun, and it is called Mercury. Now, let's visit the first planet from the sun. Mercury is a small planet. Its diameter is only 1.5 times of the moon. And the surface temperatures on Mercury fluctuate significantly because this planet doesn't have air. The day side of Mercury is cooked by the sun to 800 Fahrenheit degrees. And the night side is cold. It is minus 280 degrees. So we don't see that level of fluctuation on planets that have air, because air is acting like a blanket and keep the temperatures at a steady level. So that's the reason we don't have very cold night time and a very hot daytime on Earth. It takes only 88 days for Mercury to orbit around the Sun. It has the shortest orbital periods. This is the result of Kepler's law. Closer the planet to the Sun, it revolves faster. Mercury rotates around its axis at very slow rates. Mercury has 3-to-2 spin-orbit resonance. That means the time it takes for 3 rotation is 2 orbits. With other words, 3 Mercury days equals to 2 Mercury years. Strange, isn't it? Rotation and revolution is always confused terms in astronomy, and if you are confused about this, don't worry. Rotation, when we say rotation, we are meaning the planet rotating around its axis. So, for example, it is called a day on Earth. And revolution is the orbit around the Sun. So, at Earth, we call it a year. 2 spacecrafts visited Mercury in 1974 and 1975. Back then, the spacecraft called Mariner 10 flew by Mercury that took remarkable images of its surface. So the Messenger spacecraft visited Mercury relatively recently in 2011 and orbited Mercury for 4 years until it ran out of fuel and crashed on its surface. So we are looking at an image taken by Mariner 10, and if we think about the technology, the camera technology back in 74 and 75, that's a remarkable image. And there are actually even more remarkable images taken by the same the spacecraft. If you visit NASA mission website, that's a great resource. You can find out all the information and archived images and video for the space missions. So the Messenger was also a later spacecraft, and that orbited the Mercury. And recently, the European Space Agency, ESA, has launched another spacecraft in 2018 in partnership with Japanese Aerospace Exploration Agency called JAXA. That spacecraft is expected to arrive around Mercury in December 2025. It is called Bepi Colombo, and it carries 2 different modules, and one module is going to study the magnetosphere of the Mercury, and the other is going to research the surface of Mercury. So that both modules are going to bring us great data. So our general understanding is the conditions on Mercury so far. We always said it's not great to support life. But the science has always full of surprises. A scientific article just published on March of this year suggests that Mercury may have conditions below its surface that may support organisms. And the next planet, which we'll actually continue next week, is Venus. Venus is a little bit strange planet because the rotation of Venus is a little different than other planets, and also the conditions on Venus is a little strange. We will leave Venus for next week, but for this past coming weekend, which is a holiday weekend for United States, there's going to be a lunar eclipse. It's called penumbral lunar eclipse. So that means only the Earth's shadow will fall, not the full shadow, but the fuzzy shadow will fall on the surface of the moon. So the best time to watch this, if you have a clear sky, it's going to be about full moon at that time. It's going to be Saturday, late evening. It will start from around 10:30 Central Time, and it will go 3 to 4 hours. But what you should expect is only you should see part of the moon, not disappearing completely, but getting a nice shade in the best case. So that's not going to be a spectacular full moon, the lunar eclipse. But still, if you're out and looking into the sky, don't forget to look at the moon. Let's take some questions from our audience. And did you say cold stars give red lights? Yes, because the temperature of a star determines its color. The stars are actually emitting light in many different frequencies, and one of the set of the frequency, or let's say one of the frequency window, are the colors as we know. Those are the low frequency colors, red, and the high frequency colors like violet. We cannot see lower than red frequencies, and we call them infrared. Infrared is pretty much, if you have the old style remote controls, for example, they have like a LED bulb emitter, the little emitter in front of them. When you press the buttons, you don't see any light coming out. But actually, if you use a camera, point your camera to your remote control and press the buttons, you will actually see there's a light blinking. It is signaling to the TV. So those frequencies are called infrared, and our eyes are not sensitive. We don't see those. On the other side, ultraviolet is also a frequency that we don't see. But between we see the colors, and in the cold stars, the red colors are emitted more intensely than other colors, so that's why we see them as red. And in the blue stars, it is the opposite way. And for the most intense color emitted from the sun is green, but we don't see it as green as for the reasons I mentioned earlier in the video. So is Mercury always hot? It depends on which side of Mercury, because Mercury doesn't have air. It doesn't have an average temperature we can talk. So the side facing the sun, the day side, is extremely hot, 800 degrees Fahrenheit, and the other side, the night side, is minus 280. Is there life on Mercury? The general answer to that is no. Mercury, because of especially the temperature conditions, not a good place to support life. However, as I mentioned, just back in March, a scientific paper published and suggested that, and it is also like scientific suggestion, it is different than this is how it's saying this is how it is. It may be possible that under the surface there may be great conditions to support not life as as we know of on Earth, but maybe like microorganisms. And this is actually primarily we are looking in the solar system. Can you please explain how the rotation is longer on Mercury? Well, the rotation rates is because it is so close to the sun, the Mercury is under the great gravitational influence on the planet, on the Mercury. And this becomes actually more important, this gravitational influence, because in the earlier phases of the solar system, because currently the Mercury's interior is much colder than it was back in the early stages of the solar system. And in the early stages, there was like a molten interior. And when you have a big gravitational influence right next to you, and that gravitational force is actually acting like a braking mechanism on Earth. Moon is doing the same effect on Earth and causing tides, and rotation rate on Earth slows down just by a few seconds every year. So that happened on Mercury too. So that's why Mercury is slowly rotating planets. What is the terrain like on Mercury? Are there any rocks? Certainly, there are. When we look at the Mercury, if we have the image right now we are looking at on the screen is the image taken by Mariner 10, we mostly see craters. Those are, and also some of the craters are not formed by the asteroid impact. Some of the craters are actually formed with the earlier volcanic activity on the surface of Mercury. So yeah, certainly there are a lot of rocks on Mercury's surface. I wish some of those spacecrafts were capable of bringing some of the rocks on Mercury, because it would be very interesting. What type of star is the Sun? The Sun is, with the size classification, it is called a dwarf star. But again, dwarf in astronomy doesn't mean small. Dwarf means average star. And with the temperature classification, it is a G2 type star, which tells us the surface temperature of the Sun is nearly 6,000 degrees. Great questions. So we'll continue on our live streams with the part 2 of the solar system tours, and we'll then start with the Venus and cover some other planets. But always, please put your questions, if you have any, in the comments chat, and we'll get them answered quickly. And thank you very much. It was a great live star stream with you again, and hope to see you next week. Bye-bye.